Are the two measurements shown here the same? To a scientist, these numbers are numerically the same, but they were produced by two different measuring devices. The second measurement was taken with a measuring device that had much more accuracy. The way you report a number in physics communicates the accuracy of your measuring device. The last digit in your measurement is always an estimate. The significant digits in a measurement are all the digits in your measurement that you are certain of plus your estimate. The first measurement has 3 significant digits and the second one has 4. Look at the 3 measuring devices shown here. If you were measuring volume with these 3 devices, which one do you think would give you the most accurate measurement? If you said the third one, you would be correct. The smallest division is 0.1 milliliter. When we report a number in physics, we always show the accuracy of our measuring device by including all the numbers we know for certain and the one digit we had to estimate. The number at the end of these 3 measurements represent an estimate done by the measurer. The first measurement has 2 significant digits, the second one has 3, and the third one has 4 significant digits. Rules for counting significant digits. When you multiply, divide, or add numbers in physics, your answer must reflect the number of significant digits that were put into your equation. So you must be able to find the number of significant digits in all the numbers you're putting into your equation. Rule number 1, non-zero digits are always significant. Look at 46.78, that has 4 significant digits. 3.94 has 3. They're all non-zero numbers. Any zeros between 2 significant digits are significant. So that 0 between the non-zero 4 and 9, that's significant. So that is 3 significant digits. So a 0 trapped between non-zero numbers is always significant. Rule number 3, a final 0 or trailing zeros in the decimal portion of a number are always significant. The leading zero, 0.0, that doesn't count. Only the bolded numbers are actually significant. So 7, 0, 3, 0, all of those are significant. That number has 4 significant digits. Again, leading zeros don't count. So 8, 0, 0, those last 2 zeros count. That has 3 significant digits, the non-zero 8 and the 2 zeros that are trailing. The third rule is the final 0 or the trailing zeros in a decimal portion are significant. Let's look at 2 more examples. 6.500 times 10 to the 4th has 4 significant digits because trailing zeros count in a decimal. 3,400 has only 2 significant digits because trailing zeros do not count when it's not a decimal. Trailing zeros only count in decimals. So let's finish with 4 more examples. We have 0.09060. This is a decimal. The trailing 0 counts, and the zeros in between, non-zero numbers do as well. That's 4 significant digits. Another decimal, trailing zeros count, but we start counting. The leading zeros do not count. We don't count the first 3 zeros, so 400, that's 3 significant digits. This is not a decimal, so the trailing zeros don't count. That's only 1 significant digit. And the last one is not a decimal 2. Trailing zeros don't count. 2 significant digits. So leading zeros in a decimal don't count. Trailing zeros in a decimal do count. This is the end of my presentation on counting significant digits.